when you are doing those, you have to verify your criteria, and that is part of the question. So you can't just skip over that. So Rolle's theorem has 3 criteria with it. What are they? You guys know? Mm-hmm. On the closed interval a to b. What's the second one? On the open interval a to b. And then the third one? Mm-hmm. And if those 3 things are true, then you can do Rolle's theorem. And what does Rolle's theorem tell you? Mm-hmm. Okay, so please, on those questions, make sure I can tell that you verified your criteria. Usually we just kind of said criteria and listed them. And so you don't necessarily have to show a lot of work for it. If it's polynomial, we know it is continuous and differentiable. If it is not a polynomial, you had to do the derivative and see is there anywhere it doesn't exist, and make sure that wasn't a part of your interval. Mean value theorem, I have too many bullets here. There's only 2 criteria for it. Those are the same as the first 2 criteria for Rolle's theorem. So the function is continuous on the closed interval a to b, and it is differentiable on the open interval a to b. And if those 2 criteria are met, what is the result? The derivative is equal to the slope between the endpoints. For some x between a and b. All right, so make sure before tomorrow you look back over those 2 things, know what they're telling you. How do we find a critical point? Where the first derivative is 0 or undefined. And those are the places where the local max and min happen. How do we find inflection points? And those are the points where the concavity changes. How do we find absolute maxes and mins? So we find all the critical points, then we plug critical points and endpoints into the original equation. And then you know the highest y value is your absolute max, your lowest is your absolute min. Okay. Let's talk about what the graph might look like a little bit. If I said your graph is concave up and increasing, what's concave up mean? It's curving upward and it's increasing. So what would it look like? Yeah, something like this. It's curving upward and increasing. If it's curving upward and decreasing, what would it look like? Concave down and increasing. So it's still going up, but it's curving the other way. And then concave down and decreasing. So you have to pay attention to those when you're drawing your graphs. You'll have to look at where your graph is concave up or down, increasing, decreasing, and know how to draw those things. How do we find vertical asymptotes? And the equation is always x equals a number. Horizontal asymptotes are y equals a number, and how do we find those? And then I just had a couple practice problems for us. So there were some like this on the study guide, and they're kind of challenging. So I thought it wouldn't hurt to try a couple more. So this one is a graph. So the first question, if this is the graph of the original function, so this is my function, where do we have maxes and mins? So what is the max on this function? Okay. And actually, you don't even have to give full order pairs because my question said give the x values of the max. So we could just say -1. If I asked for the full max, you give me the order pair. Where are the minimum values on this graph? It's probably not exactly -5. It's really close to it. Kind of hard to tell. Maybe -4.75. And again, the 3, we didn't make it quite there, so maybe +2.75. We're just trying to estimate those. All right. Inflection points. Those aren't as obvious if you're just looking at a graph. You're not going to necessarily see an order pair. I usually have you mark them with X's so we can kind of see where they are at. So if I look at this one, can we kind of approximate where our inflection points would be? So if we look, this is curving upward. This is still curving upward, but at some point it turns down. So we have to have an inflection point in between here. So maybe kind of like the middle. Looks like maybe about right there. So I would say -3 is an inflection point. So here we're curving down, but at some point we switch to curving up. So it looks like the other one would be approximately at 1. All right. Do those make sense to everyone? So if I give you a question like this on the test, we'd be okay. Now I'm going to switch it and say, okay, pretend this is not the original function. This is the derivative. So this is really testing if we know what everything means. I want the max and mins if I'm looking at my derivative. How do we find maxes and mins of a function? we set the first derivative equal to 0. So we had maxes and mins anywhere where the first derivative is 0. So those had to happen at -4, -3, okay. How do we tell those ordered pairs? Sorry, that wasn't -4, it's -6. When we do those, we find our critical points, right? And then we always make a sign line. So we have 4 of them. Before I get to -6, my graph of the derivative was positive. What does that tell me about my original function? It was increasing. And then after that, it was decreasing. Okay, from -3 to 1, it was from 1 to 4. And then after 4, increasing. So, at 6, you went from increasing to decreasing. So what does that tell you? We have a max. At -3, we went decreasing to increasing. So that's a min. At 1, increasing to decreasing. So that was a max. And at 4, decreasing to increasing. So that was a min. Does that make sense? Second thing, I want the inflection points. If you are looking at the first derivative, how do we get inflection points? It's when the second derivative is 0. So if this is the first derivative, the second derivative will be 0 when this has horizontal tangent lines, or maxes and mins. So when would the derivative of this function be 0? Like right here and here we have horizontal tangent lines. So those maxes and mins of my first derivative will be when the second derivative is 0. So my inflection points are going to happen at, we said it was approximately -4.75, -1, and +2.75. Okay, these can be a little bit confusing, but think back, you guys know all the applications. You just have to think, okay, if I'm at the first derivative, how do we find the inflection points? So think about what you know. Right. Last one. Sorry, it kind of got cut off. So if this is the graph of the function, so this is kind of the same thing. I want to know if this is the original function, where would it have maxes or mins? Do you guys want to take a second and try these on your own first? So if we are looking at the original function, maxes and mins are just the high and low points on this graph. Would you count endpoints here? No, because we're really just looking at local, plus, you know, this wouldn't even count as an absolute anything. So my maxes happen where? -4. And my mins were at -1.5 or -3/2 and +3. inflection points where the concavity changes. You will have an inflection point in between every maximum and minimum, okay, when we're looking at that. So we see this is concave down, this is concave up, so somewhere in the middle we change, and it usually is just about in the middle of those two. It's not an obvious point here, so it is kind of an approximation. What do you guys think? Negative 2.25 maybe? Okay, then we had to change again here because we were curving upward, then curving downward. So maybe about -1. And then again here at 2. Are there any more? Yeah, this was curving upward and that's curving downward. So we have one more. Where is it? Somewhere in there. So 3 point, what? What did you approximate it as? 3.75. It's not quite where I drew mine. So those inflection points we are somewhat approximating because it's not quite as obvious, but we should be close. Is that okay with everyone? All right, if you are actually looking at the derivative, so if this is my derivative graph, we're going to answer the same questions. So if this is the derivative, maxes and mins happen when the derivative was 0. All right, so if I look at that, the -4, technically it's 0 here, but the graph doesn't exist before, so would it be anything? No. Okay, so it's 0 at -2, -1, +2. So before -2 it was positive, in between negative, after 1 positive, negative. So your maxes happen when you go from positive to negative, increasing and decreasing. So we have a max when x is -2. At -1, that was a min. +2, increasing, decreasing again. Did you guys get those? Then inflection points are when the second derivative is 0. So it's when this has a horizontal tangent, or in other words, where this has maxes and mins. So all of those maxes and mins up here, those are going to be your inflection points. So we have -3, -3/2, +1/2, +3, and +4. Where does this not exist? Does not exist at x equals 0. So that means Rolle's theorem requires it to be differentiable. The interval we are looking at is between -1 and 1. Is 0 in that interval? Yes. So the function is not differentiable at x equals 0. Since this is in the interval, Rolle's theorem does not apply. It doesn't contradict anything because it didn't meet the criteria for Rolle's theorem to work in the first place. Is that one okay? Um, 15 we are talking about the graph. But I told you that this was the graph of the derivative. So we want to know when the function was increasing and decreasing. So think about how we find increasing and decreasing. Increasing happens when what is true? Thank you. When what's positive? Okay, when we find increasing, decreasing, think about when we do the whole problem. We do our critical points, we make our sign line. Anywhere the first derivative is positive, the graph was increasing. If the first derivative is negative, the graph was decreasing. So because this graph is the derivative, the increasing piece is where this graph was positive. So it's positive between 0 and 1 and between 3 and 5. It's decreasing where this graph was negative. So that's between 1 and 3 and 5 and 6. Do you guys see that? So part B wants to know when this has a max or a min. I didn't even ask which was which, just tell me all of them. So if you think about what we do to find critical points, we ask when the first derivative is 0. So we have maxes and mins every time the first derivative was 0. So when all does that happen? 1, 3, and 5. If I did ask you if it was a max or a min, you could think about your sign line. Before 1 it was positive, between 1 and 3 negative, between 3 and 5 positive, afterwards negative. So 1 would be a max, 3 would have been a min, and 5 was a max. Does that make sense, everyone? So you just have to watch if I'm giving you the graph of the function or the derivative. 16. This might be my favorite question. So I am asking you to find your inflection points. Okay, so 3 different times we're going to find inflection points. The first time, I'm telling you this is the original function. So inflection points happen where your concavity changes, right? So if I'm looking at this, we're asking where does the concavity change? So this is concave down, but at some point it switches to concave up. So about at 3, and concave up, but then it's concave down again. So about 3 and 5, the concavity changes. So those would be the inflection points. Now I want the inflection points, but suppose we are looking at the derivative, the first derivative. Inflection points are when the second derivative is 0. So it's like saying, when would the derivative of this graph be 0? So that happens at your high and low points, right? Anywhere you would get a horizontal tangent. So that would be at 2, 4, and 6. See, if we are looking at the second derivative, inflection points are when the second derivative is 0, so that's at 1, 4, and 7. Do you guys see that? Some good thinking questions. Let's work backwards. We'll just kind of quickly go through the answers and see if we need to talk about anything. Number 5, your critical points are plus and minus 2. The top is a quadratic, but it doesn't factor nicely. If you do the quadratic formula, you get imaginaries. So the only critical points are when the denominator is 0. 6 and 7, roles and mean value theorem. We did those on our other sheet already. Number 8, so it's a polynomial, so you know it's continuous and differentiable. If you plug in 1, you get -4. If you put 3, you get -4, so the criteria is met. So you set your derivative equal to 0, and you get 2. Number 9, it's a polynomial, so it meets the 2 criteria, continuous and differentiable. Mean value theorem says somewhere the derivative equals the slope between the endpoints. So you have to plug in your endpoints. If you put in -2, you get 0. Put in +2, you get 4. Find the slope between those, which is 1. So you set your derivative equal to 1, and you get plus and minus 2 radical 3 over 3. Number 10, you are just drawing a graph that would work, so continuous from 1 to 5. So it didn't necessarily have to start and stop there, but there were no breaks in the middle. You have an absolute min when your x is 2, absolute max when your x was 3, and a local min at 4. So something along those lines. Number 11, absolute max was right here, 4, 5. Absolute min would have been this point, but it was an open circle, so there is none. Local max, so this would be 1, but it's open, so it doesn't count. The 4, 5 can count, and also the 6, 4. Local min, we need to count this 1, 3 because it is lower than the surrounding points. 2, 2, and 5, 3. Is that one okay? I'm going to go to question 2. Question 2, your vertical asymptotes, x equals -2, x equals 1. Horizontal, y equals 0. Number 3, if the first derivative is 0, it's a max or a min. If the second derivative is negative, it's curving downward, so that means 2 had to be a local max. B, the first derivative is 0, so that's a max or min. Second derivative is 0, that means the concavity is changing. So we don't really know if it's a max or min. All you could really say is that it's both a critical point and an inflection point. Nothing beyond that. Number 4, critical points are 1 and 2. Sorry, -1 and 2. Check those and your endpoints. So your absolute max is -1, 8. Absolute min is 2, -19. The others, I am probably not going to go through the whole thing because I know most of you have already checked those where you're working on them. But certainly if you need to look at something, you can. What else do we need to work out? Number 9 was asked. What other questions do we have? Number 4. Okay, what else? Here's your graphs for A and B, so you can kind of make sure those are on the right track. Let's look at 4 and 9 then. Let's see how much time we have left after that. Alright, so number 4, absolute max and min. That means we need our critical points. So we do our derivative. So that would be a 6x squared minus 6x minus 12. Take out a 6. Set it equal to 0. So we get +2 and -1 for our critical points. The interval we are looking at is from -2 to 3. So first you check, if you have critical points that aren't in the interval, we don't use them. These are both in the interval. So we have to check our endpoints and our critical points. And we are plugging these back into the original equation. So if we put in -2, get -16 minus 12, so -30 plus 24, so 6 plus 1. -3. Okay, if we put in -1, so -2 minus 3 is -5 plus 12, 7 plus 1 is 8. Put in 2, 16 and then put in our 3. Okay, so we are plugging into the original equation. So the max is just the highest number, so that would be 8. The min is the lowest, so that would be the -19. So is this one okay? Number 9. So it's mean value theorem, so you have to check your criteria. Has to be continuous and differentiable. You can just tell me a polynomial. So continuous and differentiable. Now that being said, you have to tell me that, because if you don't, I'm going to assume you didn't think about it, and so you lose credits, because we can only do mean value and Rolle's theorem when the criteria are met. So then we think about what mean value theorem says. It tells us that somewhere the derivative is equal to the slope between the endpoints. My endpoints were -2 and 2. So we need the y values. If you plug -2 in, you get 0. Plug in 2, you get 4. So if we do the slope, y2 minus y1 for x2 minus x1, we get a slope of 1. So it means the derivative has to equal 1. So that means 3x squared is equal to 4. X squared is equal to 4/3. Okay, to get rid of a square, we square root, plus and minus. So square root of 4 is 2. We can't do the square root of 3, but it's bad notation to leave a radical on the bottom. So that's 2 radical 3 over 3. You should verify those are both in your interval. These are, so they both count. Otherwise, if one of them wasn't, you would just list the other one. We have a little time left. Do you want me to go through any on question? Yeah, right?
For number 12, what was the absolute maximum?
Your absolute max was 0, 2. Your absolute min was -5, and then it was like -2.289.
And then our critical point was at 2?
-2.
Oh, okay. I see. Thank you.
You're welcome. Anything, guys? All right, pick one, A, B, or C. We'll look at as much as we can get through for one of those. How about, let's do one that has asymptote. Do you want to look at C? So, vertical asymptote, we know and domain are very closely related. So domain in a fraction, the bottom can't be 0. So x can't be positive or negative 2, or you could write that as negative infinity to 2, union, to negative 2, union negative 2 to 2, union 2 to infinity. B, I asked for x and y intercepts, so the x-intercept is when you set this whole thing equal to 0. And you get 0. Y-intercept, put 0 in for all of your x's, and you get 0. We skipped C, part D, asymptotes. So vertical asymptote, x equals what makes the bottom 0. And we already found that in our domain, negative 2 and positive 2. For a horizontal, you have to do the limit as x approaches positive and negative infinity. So our trick was to divide everything by the highest power of x. So we get 1 over x divided by 1 minus 4 over x squared. A number over infinity goes to 0. So this is 0. So our horizontal asymptote y equals 0. All right, then part E said increasing, decreasing. So we need our derivative. We have to do the quotient rule. So low, d high, derivative at the top is 1, minus high, d low, over low, squared. So we get negative x squared minus 4 over x squared minus 4 squared. Then we need critical points. So if you set the top equal to 0, you get x squared equals negative 4, and when you try to square root, you're getting imaginaries, so we can't use that. Critical points are where it's 0 or undefined, so if you set the bottom equal to 0, we get plus and minus 2. So those are the critical points here. So to check increasing, decreasing, we do our sign line. Test point smaller than negative 2, in between them and bigger. Put it into the derivative. So if we put in a negative 3, we get negative 9 minus 4, which is negative. 9 minus 4 squared is positive, so that section is negative. Put in a 0, you get a negative over a positive, which is negative. Put in a 3, you also get negative over positive, which is negative. Can you say decreasing from negative infinity to infinity? No, because those are asymptotes. So we have to be decreasing from negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Now, if it were a polynomial, then you could say negative infinity to positive infinity. All right, so then maxes and mins, if it never switches, increasing, decreasing, did we get any maxes or mins? No. So part F is no max or min. If you did have them, remember we need ordered pairs, so you put them into the original to get your y. Okay, part G, inflection points and concavity. So we need the second derivative. So low, d high, minus high, d low. Don't forget your chain rule, times derivative at the inside. Over low squared, so it would now be to the 4th. What can you do on this? They all have an x squared minus 4. So we get negative 2x cubed plus 8x on this one. This is a minus 4x, so we need to distribute the negative 4x. So far, have you guys gotten this one right? You did okay on it? So we get 2x cubed plus 24x over x squared minus 4 cubed. So inflection points. We know when the denominator is 0. So we have the plus or minus 2. If you set the top equal to 0, you could take out a 2x. Does x squared plus 12 ever equal 0? It would be imaginary, so that doesn't count. But 2x will give us a 0. So for concavity, do our sign line. Put them into the second derivative. So if you put in -3, you get a negative. Put in -1, get a positive. +1 gives us a negative, and +3 gives us positive. So this is concave up, -2 to 0, union 2 to infinity, concave down from -infinity to -2, union 0 to 2. All right, so on your graph, everything you found, I expect you to plot. So x and y intercepts were 0. We have vertical asymptotes at +2 and -2. Horizontal asymptote at 0. No maxes or mins to plot. My inflection points, 2 and -2, those were asymptotes, so they're not actual points. At 0, if you put 0 into the original, you just get 0. So that is an inflection point there. So then we know our graph starts out curving downward. So curving downward, it can look like this or this. But this graph was always decreasing, so it's curving downward and decreasing. Plus we know around asymptotes, your graph needs to be approaching them. Okay, so then we are curving upward and still decreasing. Hit our inflection point, now we're curving downward. Final one, curved upward and decreasing.